In this video, we are going to express ax squared plus bx plus c, that is the expression, the quadratic expression, in the form a x plus b in brackets squared plus q. You will find this on page 249 in the Namibian Ordinary Level Mathematics textbook, y equals mx plus c to success. We shall now show you another way to find the turning point of a quadratic graph by expressing the right-hand side, that expression, quadratic expression, in this form. Now, let's look at an example. Write this in the form this. Hence, find the turning point and indicate whether it's a maximum or a minimum point. Now, don't take the whole equation. Just take the right-hand side, that expression. Okay, now how do you do it? Make sure that the coefficient of x squared is 1. So this is we did it in completing the square. It's almost like completing the square, but it's not with an equation, it's with an expression. Okay, because in the equation it works like this. Whatever you do on one side of the equal sign, you must do on the other side of the equal sign. But this is an expression. So whatever you add, you must subtract in order that it cancel out, because you are just working on one side of the equal sign. Okay, but let's show you in an example. So we are going to use the method completing the square, but only with an expression. So make sure the coefficient, just like in completing the square, can you remember? We made sure that it was 1. Okay, so it is 1. So what I do, instead of moving this constant to the other side, I just leave a space and I just move it a little bit to the right hand side. Okay, so make sure the coefficient is 1, move the constant term to create a space after the middle term, because you are going to make your perfect square here. Now, can you still remember how did we make the perfect square? We take the middle value, okay, and we divide it by 2 and we square the result. Okay, so basically we're going to take that negative 4, divide it by 2 and square the result. But there it stands now. Now, to balance the expression by subtracting the same value after the constant term, you cannot just add this. You must, whatever you add, you must also subtract, so that if I work back, it can cancel out. Okay, and this is the only difference, is that I'm working on one side, not on two sides of the equal sign. So now I'm going to simplify. Now remember, this is still going to be my perfect square. Okay, so I just simplify a little bit, just to make it a bit easier. But now, factorize the first 3 terms, which I show you, as a perfect square, and simplify the last 2 terms. So can you remember how did we factorize? We take this, we take the middle, and then if you say negative 2 times negative 2, it will be positive 4, and actually you just take that 2, okay, because there is the sign. If that sign there is a positive, this will be a positive. If this is a negative, then this will be a negative. And now I just simplify the last 2 terms. So it's 4 minus, and remember this becomes a 4, so that becomes 0. Okay? So now I'm sitting with it in this form. So there was it, and I substitute. Now this is very interesting. You can determine the turning point, because you must take the negative, and I want to make it red, take the negative of this value and just take that value, and there is the, so if this is, in this case, it's going to be negative 2, so if a negative times a negative, it will be a positive, so it's positive 2, so actually that sign in front of the constant must just change to the opposite, so that's why in this case it's a positive, and then just take that value of q, which is just 0, and this is the point. Now this is very interesting. This was the expression used in the quadratic equation of example 16. Go back to example 16 and compare the turning points. Now it's going to take me a while. Remember, it's 2, 0, but I still want to show you. So I just have to go back, and then I can do it here. I think this is example 16. So let's just move it up a little bit. And then can you remember the turning points there? What was the turning? Do you see x squared minus 4x plus 4? And the turning point, if you were drawing the graph, was 2 and 0. And now we go back. Okay, and there it was 2 and 0. So this is another way of finding the turning point without drawing a graph. Very useful. I want you to stop the video and I want you to do just 2. So do for me number A. I like to start always with A. And then do for me, okay, that's also 6. I don't want to give a number E. And again, you can continue the video as soon as you are finished. Okay, this is try now 19. Okay, now start with number A. Now first write the equation, the quadratic equation, and then remember, I'm not working with the whole equation. I'm just going to take this expression and I'm going to write it in that form. Now how do I do that? So let's take our expression. It's going to be x squared plus 6x, and I'm even going to already start minus 5. So just leave a space. Then can you remember middle value, which is 6? I just want to do it here. So 6 divide 2 and I square. So it's actually 3 squared. So then I add, now I want to, sorry, I just want to play with color a little bit. I add 3 squared, but I must also subtract 3, playing with that color, 3 squared. Because it must cancel out so that I can work. Then I didn't change anything on my expression. Okay. Now I said what you do is you are going to take this first 3 terms, okay, and you work with the last 3. But start with the first 3 and just go, I just want to get my pen. So it's x plus 3 squared. So you just take that without the square, that without the square. And this I just simplify. So it's minus 5 minus 9. Do you agree? Okay. So if I'm going to do that one, I'm going to simplify it further. So it's going to be x plus 3 squared minus 14. Now, therefore, this is now in this format. But the turning point will be, remember I changed this sign so it becomes a negative. And I just take this sign, grab the sign in front, just take it as it is, and it's negative 40. And that's the turning point of this graph. Very useful. Okay, let's do number E. Again, maybe stop first the video, try to do it after you see A, and then try to do it. It's really going to help you. It's also a method that we use in the next level of mathematics. Okay, so let's start with number E. So it's going to be y equals x squared minus 8x plus 7. So, and in this case, again, I just take out the expression. So then I'm going to start, and I'm just, I think I'm going to leave that space. So leave the space and say plus 7. Okay. And now I'm going to start with it, and I'm just going to, I'm going to find this space here. So remember how I do it? I take this middle, you can say negative, it's not a problem. You can leave out the negative also, and I square. I prefer that you simplify this. So then it's going to be, okay, it's negative 4 squared. Then I add negative 4 squared, and I subtract negative 4 squared. And remember, work with the first 3, work with the last 2. So the first 3 is a perfect square now because I created it. So it's x, it's that sign, but it's usually also that sign. but don't write it twice, don't make it a positive. Then put the square, and now just simplify. You can put that step, not to make mistakes. First do that, and then it's going to be x minus 4 plus, no, it's not going to be a plus, it's going to be a negative, because it's 7 minus 16, so it's going to be negative 9. And then again, my turning point is going to be, change this sign, positive 4, keep this sign, negative 9. And there is my turning point. And because I was seeing that it was a positive a squared, positive smiley, so meaning the legs will be like this, so meaning it will be a minimum point. Okay, let's go to the next example. Okay, now if you look at this example, write this in the form of this, hence fine. Now the problem in this case is that this is not a 1, and I must first make it a 1, and now it complicates it a little bit. Okay, so I cannot divide because it's not the equation. I can only take it out as a common factor, and that's what I did. I take negative 3 out as a common factor. Now remember, the signs will change. Now I do exactly what I did with the previous example there. Take the middle term, divide 2, square, okay? Simplify the first 3, make it as a perfect square, simplify that, but keep your negative 3 in front. And then after you came to this step, don't forget, don't multiply it in, just multiply it in front of this bracket. So it's actually just this. Multiply with the 1 times negative 3 is this, but multiply the negative 3 with the negative 2, and it will become positive 6. And then again, if I must find my turning points, again, you don't have to focus on that. Just change that sign, negative 1, keep that one, 6. Okay. I want you to stop the video, and I want you, and I'm going to let you do two. Do number 1 and do number 2. Again, you can continue the video as soon as you are finished. Okay, let's start. Number 1. The quadratic equation is y equals minus x squared plus 10x minus 21. Now take that expression, minus x squared plus 10x minus 21. Now don't forget what we did. I take negative 1 out as a common factor. Okay, I'm just going to do it like this. So it's going to be x squared, it's just going to change the signs, minus 10x, leave your space, plus 21, and close the bracket. Okay, now remember I closed the bracket too early. The bracket will be closed there. So remember, I'm going to add something, but that same thing I'm going to subtract. What is the thing that I'm going to add? I'm going to take this middle, negative 10, and I divide it by 2, and that will give me negative 5. So it's going to be negative 5 squared, and this is also going to be negative 5 squared. Okay, now I'm going to bring in another bracket. It's almost like, because I'm forming another, it's just, if you want, no, I will bring it in now. So it's going to be that negative 1. Now I bring in the bracket because I want to form a bracket. So first 3, last 2. So in this case, it's going to be x minus, and then this one, 5 squared. Okay, and this is going to be plus 21 minus, actually that 25. Okay, I put in the extra step just to get you not confused. So that is going to be 21 minus 25, and that is going to be negative 4. Okay. Now then I must not write a positive. then it's going to be negative 4. Then close the bracket. Now, it's almost like, remember there's a 1. You just multiply it with the number in front. So you're basically going to get negative, that 1, you can leave out the 1. But here, a negative times a negative is positive 4. So therefore, the turning point, this time I'm writing it a little bit out. Okay, so what is the turning? Remember, change the sign, so it's positive 5, and keep the sign 4. And because it was negative, oh, it was a sad face, never smiling. So then you know that this point, due to that negative, you know it's looking like this, you know that this was a maximum point. Okay, so if they ask you what kind of turning point, you can say it's a maximum turning point. Okay, let's do the last one. Okay, number 2. Express this in the form, oh, they were nice, they first gave you the expression. Okay, so 2x squared plus 4x minus 3. Remember, there must be a 1. If there's not a 1, take out as a common factor. If I divide, I get 2x. If I divide, I get a fraction. Okay, I can write it already, the space, minus 3 over 2. Okay. Now I'm going to start, and I'm going to take the middle term, and I divide it by 2, and I get 1. So I'm going to add, and I'm going to subtract. And what am I going to add? I'm going to add 1 square, and I subtract 1 square. Okay, so basically now, remember, again always, your first 3, your last 2. So the first 3 is a perfect square. So keep your 2, and now if you start putting 2 brackets, then it's almost separating the different brackets. So make a square bracket. Then it's x, this, and it's this, and this sign. And then it's minus 3 over 2 minus 1. So it's actually, this is minus 1.5, minus 1, so it's going to be minus 2.5. You don't need a calculator. Okay, so this is going to be, okay, I'm going to make it a little bit long, putting this step, just to show you it's minus 2.5. Then. Okay, and now you can but remember, just multiply it, not in, just in front. So if I multiply, I will get 2x plus 1 squared, and this, now what is 2 times 2.5? That is actually nice, it's 5, it's negative 5. 2.5 plus 2.5. And the signs stay the same because it's positive. And now I can, okay, so, right, that is what they asked me, express it. Answer the questions, very important, read your questions. Write down the coordinates of the turning point of the parabola. Now, do you see that this is the same as this? So therefore, I can just say turning point, and what will be my turning point? My turning will change the sign, negative 1, keep the sign, negative 5. And then the last one, number C, is it a maximum? Now, before you can answer, don't just look at this. You have to go back to the equation. Now, the equation was actually, and I'm going to write it here, the equation was y equals 2x squared plus 4x minus 3. So you have to look at the value of a. So the value of a is bigger than 0. Oh, it's positive. And if it's positive, it's a smiley face. Can you see the smile? Okay. So, and if it's a smiley face, you can see that this is reaching a minimum point. So therefore is the parameter, therefore it is a minimum point. So can I just repeat? You cannot just look at the point. You have to go back to the equation, and then you have to focus on the value in front of x squared, which is a. If it's positive, draw a picture for you, and you can see if it's like this, it's reaching a minimum point. It can go infinity up, but it's only reaching, and if it's like this, then it's a maximum point, and that's how you do it.